There's something utterly mesmerizing about the night sky, the way it stretches endlessly above us, dotted with stars that have burned for billions of years. But what if I told you that some of the most bizarre, almost unbelievable events are happening out there right now, hidden in the vastness of space? Picture this: a star that winks out of existence without warning, or a black hole humming with radio signals that sound like an otherworldly melody. These aren't scenes from the latest science fiction blockbuster. They're real cosmic mysteries unfolding in the depths of the universe, defying everything we thought we knew. Today, we're embarking on a journey through 15 of the most astonishing cosmic events ever recorded, phenomena so strange they seem ripped straight from the pages of a sci-fi saga. Imagine rogue planets drifting through the void without a star to call home, or colossal bursts of energy erupting from nowhere, powerful enough to light up entire galaxies. These aren't just curiosities, they're clues hinting at the universe's deepest secrets, secrets that challenge even the brightest minds in astrophysics. Why does this matter? Because every time we uncover one of these cosmic riddles, we're reminded of how much we still have to learn. The universe isn't just vast, it's alive with mysteries waiting to be solved. So, what can you expect from this exploration? A front-row seat to the most mind-bending events in the cosmos, each one more incredible than the last. By the time we're done, you'll see the night sky differently, not just as a blanket of stars, but as a stage for the universe's greatest enigmas. Whether it's a celestial object behaving in ways that defy physics or a signal from the depths of space that leaves scientists scratching their heads, these events prove reality can be stranger than fiction. Ready to have your mind blown? Let's dive in. That summer night in 1977, the Big Ear radio telescope in Ohio was quietly scanning the cosmos when something extraordinary happened. A sudden burst of radio waves, 72 seconds long, blared across the telescope's sensors with such intensity that astronomer Jerry Amon circled the reading in red ink and scrawled a single word beside it: "Wow." This wasn't just background static or interference. The signal was 30 times stronger than the ambient noise of space, and it came from a region near the constellation Sagittarius with no known stars or planets. Most intriguing of all, it matched the exact frequency scientists had predicted an extraterrestrial civilization might use to broadcast a message, the hydrogen line at 1420 MHz. For decades, astronomers have tried to explain the WOW signal. Could it have been a passing comet reflecting sunlight, a rogue satellite transmission? Or perhaps, as many hope, the first tantalizing hint of intelligent life beyond Earth? The truth is, we may never know. Despite countless searches, the signal never repeated, vanishing as mysteriously as it appeared. What makes this event so captivating isn't just the unanswered questions, it's what it represents. That fleeting moment of contact, real or imagined, reminds us how small we are in a universe teeming with possibilities. Think about it: if the WOW signal was artificial, who or what sent it? A civilization advanced enough to broadcast across the stars might have technologies we can't even fathom. Or maybe it was something stranger, like a natural cosmic phenomenon we haven't discovered yet. Either way, this 72-second mystery continues to inspire astronomers to scan the skies, listening for another whisper from the void. Because somewhere out there, in the infinite dark, the universe might just be waiting to surprise us again. Some stars flicker gently in the night sky, their light dancing like candle flames in the cosmic breeze. But then there's Tabby Star, a celestial rebel that doesn't just flicker. It plunges into darkness without warning, dimming by as much as 22% at times, a drop so dramatic it defies all conventional explanations. Picture our sun suddenly losing a fifth of its brightness, as if a colossal hand passed in front of it. That's the scale of this mystery. When astronomer Tabitha Boyajian first spotted this bizarre behavior in 2015, the scientific community scrambled for answers. Planets, even a gas giant the size of Jupiter, would only block about 1% of a star's light. Dust clouds, possibly, but the star's dimming pattern is erratic, with no predictable rhythm. The strangest hypothesis: an alien megastructure, a hypothetical swarm of energy-collecting satellites known as a Dyson sphere, built by an advanced civilization to harness the star's power. While that idea set imaginations racing, most researchers lean toward natural causes, like fragmented comets or interstellar debris. Yet, none of these theories fully explain the star's extreme dips in brightness. Here's what makes Tabby Star so fascinating. It's not just an anomaly, it's a mirror reflecting the gaps in our understanding of stars. We've observed millions of them, but this one behaves like nothing else in our cosmic catalog. Every time it dims, it's as if the universe is nudging us, reminding us that for all our telescopes and technology, some puzzles still resist solving. Could there be entirely new astrophysical processes at work here, something we haven't even conceived of yet? The star's unpredictable nature keeps astronomers on their toes. Unlike eclipses or transits, which follow precise schedules, Tabby Star keeps its secrets close, flaring and fading on its own inscrutable timetable. Each new observation peels back another layer of mystery, but the core question remains: what exactly is dancing in the shadows around this enigmatic star? Until we know for sure, Tabby Star stands as a humbling reminder. The cosmos is far weirder and far more wonderful than we've dared to dream. Imagine a cosmic lighthouse flickering not with light, but with bursts of radio waves so powerful they outshine entire galaxies, but only for a millisecond. That's the enigma of fast radio bursts, or FRB. These fleeting explosions of energy, first detected in 2007, arrive from billions of light years away, packing more power than the sun emits in 80 years. And then, just like that, they're gone. Some vanish forever, while others, like the infamous FRB 121102, repeat in baffling, unpredictable patterns, as if the universe itself is tapping out a code we can't decipher. What could possibly generate such immense energy in such a brief flash? The theories range from the violent to the downright surreal. Colliding neutron stars, supermassive black holes evaporating into nothingness, or even cosmic strings, hypothetical defects in the fabric of spacetime have all been proposed. But here's the twist: some repeating FRBs cycle through periods of activity and silence like a celestial heartbeat. This isn't just random chaos, there's structure here, a rhythm that defies our expectations. Could it be the spin of an ultra-dense star, or the signature of a technology far beyond our own? The lack of a definitive answer only deepens the intrigue. What makes these bursts truly mind-bending is their journey. By the time an FRB reaches us, it's traveled through clouds of ionized gas, magnetic fields, and who knows what else, each interaction leaving tiny fingerprints in the signal. Scientists can use these distortions like cosmic breadcrumbs, mapping the otherwise invisible matter between galaxies. In a way, FRBs aren't just mysteries, they're tools, helping us probe the universe's hidden scaffolding. Yet the most tantalizing question remains: are we alone in using them? While most astronomers favor natural explanations, the sheer intensity and repetition of some FRBs keep the door open just a crack to more exotic possibilities. After all, if an advanced civilization wanted to announce its presence across the cosmos, a brilliant, repeating pulse would be hard to miss. Whether born from celestial cataclysms or something even more extraordinary, Fast radio bursts remind us that the universe is still writing its strangest stories, and we've only just begun to read them. High above our planet, hidden in the swirling graveyard of space debris, lurks an object wrapped in layers of mystery, the so-called Black Knight satellite. Unlike the predictable orbits of satellites and spent rocket stages, this enigmatic presence moves against the tide, tracing a path that defies easy explanation. Stories of its existence first surfaced in the 1950s, when amateur radio operators claimed to intercept strange signals, pulses resembling a coded transmission, seemingly emanating from Earth's orbit. The legend grew when newspapers reported that none other than Nikola Tesla had detected unusual radio echoes decades earlier, whispers from the void that some believe were the Black Knight's first attempts at contact. Scientists have offered rational explanations: a thermal blanket lost during a spacewalk, perhaps, or a fragment of an old satellite tumbling in an irregular orbit. But the myth persists, fueled by grainy images and radar blips that don't quite match known objects. What if this isn't just space junk? What if, as conspiracy theorists suggest, it's something far older, an artifact from a lost civilization, or even an alien probe silently observing humanity's ascent to the stars? The idea isn't just science fiction, it taps into something deeper, a longing for proof that we're not alone in the universe. Here's where the story takes a stranger turn. In 1998, astronauts aboard the space shuttle Endeavour captured footage of an unidentified object drifting near Earth, its jagged silhouette stark against the blue curve of our planet. Skeptics called it a loose piece of equipment, but believers saw confirmation: the Black Knight watching. The truth may never satisfy either camp. After all, space is cluttered with remnants of our own exploration, from discarded boosters to lost tools. Yet the allure of the unknown keeps the legend alive. What makes the Black Knight so compelling isn't just the question of its origin, but what it represents: a mirror for our hopes and fears about the cosmos. Whether it's a relic of human ingenuity or something far more extraordinary, the mystery endures because it reminds us that even in our own celestial backyard, there are still shadows left to explore. And sometimes the most thrilling stories aren't about what we find, but what we dare to imagine. Somewhere in the depths of space, beyond the familiar swirl of our Milky Way, an invisible force is bending the paths of entire galaxies like a cosmic puppeteer. Meet the Great Attractor, a gravitational mystery so powerful it's pulling hundreds of thousands of galaxies, including our own, toward a single point in the universe. Picture a river flowing relentlessly downstream, except this river is made of stars, gas, and dark matter, all caught in a current we can't escape. The strangest part: we can't even see what's pulling us. Our view is blocked by the thick dust and stars of the Milky Way's own galactic plane, leaving scientists to piece together clues from the faint whispers of distorted starlight and the peculiar motions of distant galaxies. What could possibly wield such gravitational influence? One leading theory points to the Norma cluster, a dense gathering of galaxies about 250 million light-years away. But here's the catch: even the combined mass of those galaxies falls short of explaining the sheer strength of this cosmic tug. That gap has sparked wilder ideas. Could the Great Attractor be the heart of an unimaginably massive supercluster, a knot of dark matter we've yet to map, or even a gravitational echo from something beyond our observable universe? The more we learn, the more questions arise. For instance, recent observations suggest the Great Attractor itself might be moving, drawn toward an even larger structure nicknamed the Shapley supercluster, a cosmic matryoshka doll of mysteries within mysteries. This isn't just about an unseen force, it's about rewriting our understanding of the universe's structure. For decades, astronomers assumed the cosmos was evenly sprinkled with galaxies. But the Great Attractor revealed a startling truth: the universe is lumpy, with vast empty voids and dense concentrations of matter pulling everything into a web of invisible highways. Our Milky Way, just one traveler in this grand migration, racing toward the unknown at over 600 kilometers per second. The real challenge lies in peering through the galactic zone of avoidance, the dusty veil of our own galaxy's bulge that obscures nearly 20% of the sky. New tools like infrared and radio telescopes are slowly piercing that curtain, revealing hidden galaxies and refining our maps. Yet with every answer comes a new layer of intrigue. If the Great Attractor isn't the final destination, what lies beyond it? And what does that mean for the ultimate fate of our galactic neighborhood? One thing's certain: as long as the universe keeps tugging us toward the unseen, the greatest discoveries may still lie ahead, just out of view. The universe isn't just expanding, it's racing. Across the vast cosmic web, galaxies and galaxy clusters aren't drifting aimlessly. They're caught in a colossal current, streaming toward an unseen horizon at speeds exceeding 3 million kilometers per hour. Astronomers call this phenomenon dark flow, and it's one of the most unsettling mysteries in modern cosmology. Imagine throwing a handful of leaves into a river, only to watch them all surge in the same direction, defying the wind and the current. That's precisely what's happening on a galactic scale, except there's no visible river, just an invisible force tugging everything toward the unknown. The discovery of dark flow sent shockwaves through the scientific community because it shouldn't exist, at least not according to our current understanding of the universe. The Big Bang's afterglow, the cosmic microwave background, paints a picture of a largely uniform cosmos, with matter distributed evenly enough that no single region should exert such a dominant gravitational pull. Yet when researchers analyzed the motions of over 1,000 galaxy clusters, they found them all aligned in an eerie, synchronized march toward a patch of sky between the constellations Centaurus and Vela. What's out there? The unsettling answer: we don't know. It lies beyond the observable universe, a realm so distant its light hasn't had time to reach us in the 14 billion years since the cosmos began. This isn't just about galaxies moving, it's about the limits of our knowledge. One leading theory suggests dark flow could be the gravitational fingerprint of a supermassive structure lurking in the unobservable universe, perhaps a colossal concentration of matter, or even another universe brushing against our own in the multiverse. Others propose it's evidence of a primordial flaw in the fabric of spacetime, a cosmic wrinkle left over from the universe's violent birth. But here's the catch: these ideas push the boundaries of physics itself, venturing into territories where even Einstein's equations start to waver. What makes dark flow so unnerving is its scale. The affected region spans billions of light years, implying the unseen attractor must be incomprehensibly vast, so massive it makes the Great Attractor look like a pebble in comparison. If true, this forces us to confront a humbling possibility. Everything we've ever observed, every star, every galaxy, might just be a speck in a far grander structure we're only beginning to sense. Future telescopes, like the European Space Agency's Euclid mission, aim to map this motion in greater detail, searching for clues in the subtle distortions of ancient light. Until then, dark flow stands as a cosmic riddle, reminding us that the universe's greatest mysteries might not lie in what we can see, but in what we can't. Rising like ghostly titans from the heart of our galaxy, the Fermi Bubbles stretch 25,000 light-years into the void, one towering above the Milky Way's disk, the other plunging below, each pulsing with high-energy gamma rays. Discovered in 2010 by NASA, a Fermi Gamma Ray Space Telescope, These colossal structures glow like faint beacons in an otherwise invisible spectrum, their edges sharp as if carved by some cosmic blade. Picture two vast hourglasses stacked back to back, their sand replaced by a seething fog of particles moving at nearly the speed of light. What could have unleashed such staggering energy? The leading suspect sits at the very center of this mystery, Sagittarius, a star, the supermassive black hole anchoring our galaxy. Astronomers suspect these bubbles are scars from a cataclysmic eruption, a time when Sagittarius, a star, devoured an enormous clump of matter, perhaps a gas cloud or even a star, belching out jets of radiation and charged particles so powerful they punched through the galactic plane. The violence would have been unimaginable, an eruption lasting anywhere from tens of thousands to millions of years, flooding the galaxy's core with enough energy to outshine every star in the Milky Way combined. Yet here's the twist: if such an explosion occurred, it likely happened millions of years ago, meaning these bubbles are the fading echo of a tantrum our galaxy's black hole threw long before humans walked the Earth. But not all researchers are convinced. Alternative theories suggest the bubbles could be the accumulated winds of countless supernovae, or even the remnants of dark matter annihilations, a process where hypothetical particles collide and obliterate each other in bursts of gamma rays. The puzzle deepens when you consider their symmetry. Natural cosmic explosions tend to be messy, yet these bubbles are eerily balanced, as if sculpted by some unseen force. Could there be a regularity to the black hole's feeding cycles we haven't decoded yet? Or is this a sign of something more exotic, like magnetic fields funneling energy into precise shapes? What makes the Fermi bubbles so thrilling isn't just their scale, it's how they force us to rethink the Milky Way's personality. We often picture our galaxy as a tranquil spiral, stars drifting peacefully along their orbits. But these structures reveal a hidden temperament, a capacity for violence written in gamma rays. They're a reminder that even the most familiar cosmic neighborhoods can harbor explosive pasts, and that black holes aren't just silent predators lurking in the dark. Sometimes they roar. The next time you gaze at the Milky Way's hazy band across the night sky, remember, those faint bubbles of energy, invisible to our eyes but blazing in gamma rays, are proof that our galaxy's history is anything but quiet. And somewhere in their faint glow lies a story we're only beginning to read, one that might rewrite what we know about the forces shaping not just our corner of the cosmos, but galaxies far beyond. In the vast emptiness between stars, where distances are measured in light years and solitude is absolute, a visitor appeared, one that didn't belong. On October 19, 2017, the Pan-STARRS telescope in Hawaii spotted something extraordinary, a faint dot streaking across the sky, moving too fast to be tied to our sun's gravity. This was Oumuamua, the first known interstellar object to pass through our solar system, and it was unlike anything we'd ever seen. Shaped like a cosmic cigar, roughly 400 meters long but only 40 meters wide, it tumbled end over end, reflecting sunlight in erratic bursts. But the real shock came when astronomers realized Oumuamua wasn't just coasting. As it hurtled away from the sun, it accelerated ever so slightly, as if pushed by an unseen force. At first, scientists assumed it was a comet, venting gas and dust as it warmed, a natural explanation for the extra speed. Yet when telescopes turned toward it, there was no telltale coma or tail, no cloud of vaporized ice. If it wasn't a comet, what was it? The mystery deepened when researchers calculated its trajectory and realized Oumuamua had likely been wandering the galaxy for hundreds of millions of years, untouched by any star's pull until our sun briefly snared it. Some suggested it could be a shard of a shattered planet, ejected from a distant system in some ancient cataclysm. Others proposed an even wilder idea, a hydrogen iceberg, a chunk of frozen hydrogen so exotic it could vaporize in sunlight, providing stealthy thrust without visible debris. Then came the theory that set the internet ablaze. Harvard astronomer Avi Loeb pointed out that Oumuamua's acceleration and peculiar shape matched what we might expect from a light sail, an artificial structure propelled by starlight, perhaps sent by an advanced civilization to explore the cosmos. While most scientists remained skeptical, the mere possibility forced us to confront a profound question. How would we know if we'd encountered alien technology? Oumuamua's brief visit offered no clear answers. By the time we noticed it, the object was already racing away, leaving behind only a trail of data and speculation. What makes Oumuamua so compelling isn't just its strangeness, it's the timing. After centuries of wondering whether interstellar visitors existed, the universe delivered one right to our doorstep, only to snatch it away before we could study it properly. Was this a rogue asteroid, a fragment of an alien world, or something even more extraordinary? We may never know for sure, but one thing's certain: Oumuamua won't be the last. With telescopes like the Vera Rubin Observatory coming online, we're poised to spot more of these interstellar nomads, and next time we'll be ready. Until then, this tumbling enigma remains a tantalizing hint that the universe is far stranger and far more crowded than we ever imagined. Imagine a hole in the universe so vast you could drop thousands of galaxies into it and still have room to spare a cosmic desert stretching 330 million light-years across, where the night isn't just dark, it's almost completely empty. This is the Boötes Void, a region of space so eerily barren that astronomers nicknamed it the Great Nothing. To put its scale into perspective, if our Milky Way were placed at the void's center, we wouldn't have seen another galaxy until the 1960s, when telescopes finally became powerful enough to peer beyond our own cosmic neighborhood. The existence of the Boötes Void shatters our assumptions about how the universe organizes itself. Most of the cosmos resembles a sprawling web, with galaxies clustered along shimmering filaments of dark matter. But here, in this incomprehensible emptiness, that web frays into nothingness. When astronomers first mapped the void in the 1980s, they expected to find at least 10,000 galaxies. Instead, they counted fewer than 60, a scattering of lonely stars adrift in an ocean of nothing. How does a void this colossal even form? One theory suggests it's the ghostly imprint of an ancient cosmic battle, where smaller voids merged over billions of years, like soap bubbles combining into one gigantic cavity. Others propose it's evidence of a phenomenon so exotic it sounds like science fiction, a collision with a parallel universe, leaving behind a scar in the fabric of our own. But the real mystery isn't just the void's emptiness, it's what that emptiness implies about the universe's structure. According to the standard model of cosmology, matter should be distributed relatively evenly across space. Yet the Boötes Void defies that logic, presenting a glaring anomaly that forces us to reconsider our understanding of dark energy, gravity, and the very forces that shaped the cosmos. Could there be unknown physics at work here, something tugging galaxies away from this region? Or is this void a statistical fluke, a rare but natural gap in the cosmic tapestry? Interestingly, the few galaxies that do call the Boötes Void home are peculiar in their own right. Many are irregular in shape, as if the void's isolation stunted their growth, leaving them starved of the collisions and mergers that typically fuel galactic evolution. It's as if the void isn't just empty, it's actively shaping the galaxies trapped within it, molding them into oddities that wouldn't exist anywhere else. What makes the Boötes Void so haunting is what it represents, a reminder that the universe isn't just stranger than we imagine, but stranger than we can imagine. For every rule we've devised to explain the cosmos, there's a place like this, a silent, yawning expanse that whispers of mysteries we've yet to unravel. And as our telescopes grow more powerful, probing deeper into the darkness, one question lingers. Is the Boötes Void a cosmic aberration, or are there others like it lurking in the unexplored reaches of space, waiting to rewrite the story of everything we think we know? Most dying stars leave behind chaotic, swirling clouds of gas-turbulent farewells painted across the cosmos, but the Red Rectangle Nebula is different. Floating 800 light-years away in the constellation Monoceros, this celestial oddity looks like something drafted by a cosmic architect, its glowing gas arranged in near-perfect geometric layers. At its heart, a dying star pumps out jets of material, not in the usual messy bursts, but in precise, symmetrical cones that intersect to form a striking X shape. The result, a nebula that resembles a glowing red jewel box suspended in space, its sides so sharply defined they almost look artificial. What makes this structure so baffling isn't just its shape, it's the physics-defying precision behind it. Most planetary nebulae, a misleading term as they have nothing to do with planets, are spherical or bipolar, their forms sculpted by the chaotic death throes of their central stars. Yet the red rectangle's symmetry suggests an eerie orderliness, as if some unseen force is guiding the star's expelled material into this unnatural alignment. One leading theory points to a dense disk of dust orbiting the star, funneling its outflow into two opposing jets. But even that doesn't fully explain the crispness of the X or the nebula's layered, almost stair-step appearance. Then there's the color. The red rectangle's crimson glow doesn't come from the usual suspects, hydrogen or oxygen emissions, but from a rare class of molecules called polycyclic aromatic hydrocarbons, or PAH. These complex carbon-based compounds, often found in soot, thrive in the nebula's unique environment, absorbing ultraviolet light from the dying star and re-emitting it as that deep, haunting red. Some scientists speculate these molecules could be the building blocks of life scattered into space by stellar winds. If true, this bizarre nebula might not just be a cosmic artwork, it could be a factory for the raw materials of biology. Perhaps the most tantalizing mystery is the nebula's central star. Hidden within that geometric glow lies HD 44179, a binary system where one star has already shed its outer layers while its companion remains intact. Their gravitational dance might hold the key to the nebula's shape, with their mutual orbits acting like a cosmic loom, weaving the gas into that uncanny pattern. Yet even this explanation feels incomplete. The red rectangle refuses to fit neatly into any existing model, standing as a reminder that the universe has a flair for the unexpected. What's next for this cosmic enigma? As telescopes grow more advanced, astronomers hope to peel back its layers, searching for clues in the subtle vibrations of its light or the chemistry of its dust. But for now, the red rectangle remains a testament to the universe's ability to surprise us, a dying star's farewell wrapped in geometry so perfect, it feels like a message. Whether it's the result of unseen physics, a stellar partnership, or sheer cosmic chance, one thing's certain: in a universe full of chaos, this nebula's quiet precision is the strangest rebellion of all. Galaxies aren't just collections of stars, they're cosmic ecosystems, bound together by an invisible glue called dark matter. This mysterious substance, which outweighs visible matter 5-to-1, acts as a gravitational scaffold, pulling stars and gas into the majestic spirals and ellipticals we recognize. But then there's NGC 1277, a renegade galaxy that defies the rules. Nestled 220 million light-years away in the constellation Perseus, this compact elliptical galaxy has a shocking secret. It appears to have no dark matter at all. At first glance, NGC 1277 seems ordinary, an unassuming smudge of ancient stars, but when astronomers measured its rotation speeds, expecting the telltale tug of dark matter's gravity, they found nothing. Stars on the galaxy's outskirts moved sluggishly, as if they weren't being pulled by any unseen mass. It was like watching a car race where every vehicle inexplicably slows down at the same curve, defying the laws of physics. This wasn't just unusual, it was unprecedented. Every other known galaxy, from tiny dwarfs to sprawling giants, dances to dark matter's tune, except this one. So how did NGC 1277 break the mold? One theory suggests it's a relic from the universe's chaotic youth, a survivor of a time before dark matter dominated. Picture a primordial galaxy forming in a rare pocket of space where normal matter somehow clumped together first, bypassing the dark matter scaffolding altogether. Alternatively, it might have been stripped of its dark matter in a violent encounter, perhaps a close call with a neighboring galaxy that siphoned it away like a cosmic thief. The most tantalizing possibility, dark matter isn't missing at all. Instead, it could be hiding in plain sight, woven into an exotic form our current instruments can't detect. What makes this galaxy so revolutionary isn't just its defiance of expectations, it's the questions it forces us to confront. If dark matter isn't essential for galaxy formation, what other paths might exist? Could there be entire populations of dark matter, free galaxies lurking in the cosmos, overlooked because they don't fit our templates? NGC 1277 challenges us to rethink one of astronomy's foundational assumptions, that dark matter is the universe's great architect. The hunt for answers is far from over. New telescopes, like the James Webb Space Telescope, are peering into similar galaxies, searching for clues in their starlight and motions. Whether NGC 1277 is a cosmic fluke or a pioneer of a hidden galactic class, one thing's certain: this cannibal galaxy, devouring our preconceptions, might hold the key to unlocking dark matter's deepest secrets or rewriting the rules entirely. Deep in the constellation Serpens, a dead star spins at dizzying speeds, its beam of radiation slicing through space like a lighthouse gone mad, and circling it, a world unlike any other. Meet PSR J1719-1438b, the so-called Diamond Planet, a celestial jewel forged in the aftermath of stellar catastrophe. This isn't just a planet with a few diamond deposits, it's a world scientists believe is made of the stuff, a crystallized behemoth 5 times the size of Earth, glittering in the eternal dark. The story of how this cosmic luxury came to be begins with violence. The planet's host, a pulsar, is the corpse of a once mighty star that died in a supernova explosion. In its final moments, the star's outer layers were blasted away while its core collapsed into a neutron star, a city-sized object so dense, a teaspoon of its material would weigh billions of tons. But here's the twist: pulsars don't just sit quietly, they spin some hundreds of times per second, and their intense gravity can shred nearby objects into submission. So how did a diamond planet survive such a hostile neighborhood? Astronomers think the answer lies in its origins. Before the supernova, this might have been a gas giant like Jupiter, orbiting a star rich in carbon. When the star exploded, the blast stripped away the planet's outer layers, leaving behind a dense, carbon-rich core. Under the pulsar's crushing gravity and relentless radiation, that carbon was compressed into crystalline perfection, a diamond lattice stretching across an entire world. Imagine a pressure cooker the size of a planet, with heat and force rearranging atoms into something rare and radiant. But the real mystery isn't just how it formed, it's what it tells us about the universe's capacity for surprise. We've found lava worlds, ice giants, even planets that rain glass. Yet a diamond planet orbiting a stellar corpse that defies even the wildest sci-fi imaginings. Could there be others like it? Pulsars are notoriously difficult to study, their planets hidden in the glare of their deadly beams. But with every discovery, we're learning that the universe doesn't just create worlds, it sculpts them into impossible works of art. Here's the kicker: this planet's composition isn't just a curiosity. Diamond is an incredible conductor of heat, meaning this world might have a thermal structure unlike anything in our solar system. Some theorists suggest its interior could harbor rivers of superfluid carbon, or even exotic phases of matter we've never seen. And while it's too hostile for life as we know it, the very existence of such a place stretches our understanding of what's possible. So the next time you admire a diamond ring, remember, out there, in the silence between the stars, an entire world sparkles with the same brilliance, a testament to the universe's flair for turning destruction into something dazzling. Who knows what other treasures are waiting to be discovered, hidden in the light of dying stars? When a star dies, it's supposed to be a one-time event, a spectacular, irreversible explosion that tears it apart in a final blaze of glory. But in 2014, astronomers witnessed something that shouldn't have been possible, a star that refused to stay dead. Dubbed the zombie star, this cosmic anomaly didn't just go supernova once, it exploded, faded, and then roared back to life multiple times over the course of 60 years, defying every known model of stellar death. Imagine a firework that bursts into color, vanishes, and then inexplicably reignites in the sky not once, but again and again. That's the level of cosmic defiance we're talking about. The star, officially named IPTF-14 HLS, was first observed in September 2014 when it erupted with the brightness of a typical supernova. But instead of fading into obscurity within months, as dying stars usually do, it lingered. Then something even stranger happened. Its light curve, the graph tracking its brightness over time, didn't follow the smooth decline scientists expected. It plateaued, dipped, and then brightened again, as if the star had somehow mustered a second wind. By 2015, it had dimmed once more only to surge back to life a third time, like a phoenix trapped in an endless cycle of rebirth. What could possibly fuel such relentless resurrection? One leading theory suggests the zombie star might have been a massive, unstable behemoth, a star so large that its death throes occurred in staggered, violent pulses. In this scenario, the initial explosion ejected part of the star's outer layers, while the core temporarily stabilized, only to collapse again years later in another cataclysmic burst. Another possibility: the star might have been part of a binary system, with a companion star dumping fresh material onto the dying core, reigniting the fusion process like gasoline on embers. But even these explanations strain the limits of astrophysics. Supernova are supposed to be terminal. They don't get second acts. The implications are staggering. If stars can die in fits and starts, it means our understanding of stellar life cycles is missing critical chapters. Could there be other zombie stars out there, masquerading as single explosions when they're actually slow-motion disasters? The discovery also raises eerie questions about the fate of the universe's most massive stars. For decades, scientists assumed supernova always left behind either a neutron star or a black hole. But if a star can partially explode, survive, and then explode again, what does it become in the end? A hybrid remnant, something entirely new. What makes the zombie star so mesmerizing isn't just its defiance of the rules. It's the reminder that the universe loves a good plot twist. Just when we think we've figured something out, the cosmos throws a curveball, forcing us to rethink the boundaries of possibility. And while this undead star might be an extreme outlier, its very existence proves one thing. In the grand theater of the universe, even death isn't always final. The deeper we peer into the cosmos, the more it reveals its capacity to defy our expectations, nowhere more dramatically than with the discovery of a galaxy so massive, so ancient, it shouldn't exist at all. Meet HD1, a cosmic behemoth lurking in the early universe, a time when the cosmos was a mere 800 million years old. Based on everything we know about galaxy formation, this titan had no business being there. It's like stumbling upon a skyscraper in the middle of the Stone Age, a structure so advanced, it rewrites the timeline of cosmic history. What makes HD1 so impossible? Its sheer mass. Current models suggest the early universe was a chaotic nursery, where tiny proto-galaxies slowly merged over billions of years to form the giants we see today. Yet HD1 weighs in at a staggering 100 billion times the mass of our Sun, rivaling the heft of modern galaxies like the Milky Way, but it achieved this size when the universe was less than 6% of its current age. To put that in perspective, it's as if a toddler somehow bench-pressed the weight of an adult Olympian. How did it grow so big, so fast? One theory points to a voracious appetite. HD1 might have gorged itself on primordial gas, forming stars at a rate 50 times faster than any galaxy we've observed. Imagine a cosmic factory churning out suns at breakneck speed, blazing with ultraviolet light so intense it would have ionized the surrounding hydrogen, a process thought to take much longer in cosmic evolution. But even this explanation strains credulity. There shouldn't have been enough raw material in the early universe to fuel such a frenzy. Then there's the black hole scenario. Some astronomers speculate HD1's core might harbor a supermassive black hole, one so ancient it challenges our understanding of how these gravitational monsters form. Did it arise from the direct collapse of a massive gas cloud, bypassing the usual stellar steps? Or was it seeded by something even more exotic, like a primordial black hole left over from the Big Bang itself? The implications are dizzying. If black holes could grow this large, this quickly, it would mean entire chapters of cosmic history are missing from our textbooks. What's truly humbling about HD1 isn't just its existence, it's what it represents. Every time we think we've mapped the limits of galaxy formation, the universe hands us a paradox. This impossible galaxy forces us to confront uncomfortable questions. Are our models of cosmic evolution fundamentally flawed? Could there be unknown mechanisms, dark matter interactions, exotic physics, even multiverse influences that shortcut the slow dance of gravity and time? For now, HD1 stands as a luminous question mark in the sky, a reminder that the universe's infancy might have been far more dynamic and far stranger than we ever imagined. As telescopes like James Webb peer deeper into the cosmic dawn, one thing's certain: the more we look, the more we'll find that the rules we thought governed the cosmos are just suggestions waiting to be broken. Picture the universe not as a scattering of isolated galaxies, but as a grand, intricate tapestry, threads of invisible dark matter and glowing gas stretching billions of light years, weaving everything together in a delicate cosmic web. This isn't just a poetic metaphor, it's the hidden architecture of reality itself, a structure so vast it makes even the largest galaxies look like mere specks caught in a spider's silk. The cosmic web is the universe's skeleton, and discovering it was like pulling back a curtain to reveal the scaffolding behind everything we see. For decades, astronomers theorized that galaxies weren't randomly placed but connected by vast filamentary structures. Then, in 2014, the Sloan Digital Sky Survey finally captured visual proof: a faint, glowing bridge of hydrogen gas linking distant galaxies across the void. This was no ordinary gas. It was primordial material left over from the Big Bang, heated to millions of degrees and glowing in X-rays. Tracing these filaments revealed a pattern eerily similar to neural networks in the human brain or the branching veins of a leaf, a recurring motif of nature scaled up to cosmic proportions. What's truly staggering is the Webb scale. Some filaments stretch for 500 million light-years, threading through clusters of galaxies like highways of dark matter and gas. These aren't static roads, though. They're dynamic rivers funneling material toward dense nodes where galaxies cluster, feeding their growth over billions of years. Imagine the universe as a bustling metropolis, with these filaments as the subway lines shuttling stars, gas, and dark matter between galactic downtowns. But here's the twist. We're not just observers of this web, we're part of it. The Milky Way sits at the edge of a filament in the Laniakea supercluster, a structure encompassing 100,000 galaxies. Every star in our sky, every planet in our solar system, exists because gravity pulled us into this vast network. Even now, we're drifting along these invisible currents, drawn toward the Great Attractor like a leaf caught in a cosmic stream. The cosmic web's existence forces us to rethink the universe's story. It's not just about galaxies, it's about the spaces between them, the dark matter, threads that dictate where galaxies form and how they evolve. Some scientists even speculate that the Webb structure holds clues to the universe's ultimate fate. Will these filaments tighten, pulling everything together in a big crunch, or will dark energy stretch them to the breaking point, leaving galaxies isolated in an ever-expanding void? As telescopes grow more powerful, they're mapping this web in ever greater detail, revealing knots of dark matter and galaxies huddled along filaments like pearls on a string. Each new observation peels back another layer of mystery, showing us a universe far more connected, far more structured than we ever imagined. And somewhere in that glittering web, suspended between the threads, is our place in the grand design, proof that even in the vastness of space, nothing truly stands alone. Unlocking the universe's secrets requires tools as extraordinary as the mysteries they're designed to solve. Take radio telescopes, for instance, colossal dishes like the Arecibo Observatory, now silent after decades of service, or China's FAST, its 500-meter bowl nestled in a natural karst depression. These giants don't just listen to the cosmos, they catch whispers from billions of years ago, like cosmic answering machines replaying ancient signals. When the WOW burst erupted across Big Ear's sensors, it was this very technology that captured its fleeting cry, proving how much can hide in the static between stars. But light isn't the only messenger. In 2015, humanity gained a new sense when LIGO detected gravitational waves, ripples in spacetime from colliding black holes over 1 billion light-years away. Think of it like feeling the distant drumbeat of a storm before you see the lightning. These detectors, with laser beams traveling down 4-kilometer arms, measure distortions smaller than an atom's nucleus, revealing crashes so violent they warp the fabric of reality itself. It's a reminder that the universe doesn't just show itself, it trembles, and now we can feel it. Then there's the James Webb Space Telescope, our infrared eye in the cosmic dark. While Hubble showed us the universe's visible beauty, Webb peers through dust clouds to witness stellar nurseries and galaxies born in the cosmic dawn. Its images of HD1, that impossible early galaxy, forced us to confront how little we understand about the universe's infancy. Every wavelength we unlock, gamma rays from Fermi's bubbles, X-rays from the cosmic web's filaments, is like adding a new color to our palette, painting a fuller picture of the invisible forces shaping existence. Yet for all our tools, the cosmos keeps its cards close. Oumuamua streaked past before we could study it properly. Dark flow hints at realms beyond our observational horizon. Even the Boötes Void's emptiness taunts us, a blank page in the cosmic story. Each discovery isn't an endpoint, it's a doorway. When we finally decode fast radio bursts or map dark matter's tendrils, we won't just solve puzzles, we'll find new ones written in languages we've yet to learn. The universe's greatest lesson might be this: the more we see, the more we realize how much remains unseen. So while our telescopes scan and our algorithms sift, remember, we're not just observers. We're detectives piecing together a mystery without end, where every clue rewrites the story. And somewhere out there, in the data streams and error margins, the next great cosmic surprise is waiting. Dark matter and dark energy, these two invisible forces, are the universe's greatest puppeteers, shaping everything from the spin of galaxies to the fate of the cosmos itself. Yet despite their overwhelming influence, we've never directly seen or touched them. They're like ghosts in the cosmic machine, detectable only by the trails they leave behind. Take dark matter first. Without it, galaxies would fly apart. Stars on the outer edges of spiral galaxies rotate so fast that the gravity from visible matter alone couldn't hold them in orbit. Something unseen must be anchoring them, a cosmic glue we call dark matter, outweighing ordinary matter 5-1. Picture a merry-go-round spinning so violently that the children clinging to its edges should be flung off, except invisible hands grip them tightly, keeping them in place. That's dark matter's role, the silent, unseen force keeping the universe's structures intact. Then there's dark energy, an even more mysterious player. In the late 1990s, astronomers made a shocking discovery: the universe's expansion isn't slowing down as expected. It's accelerating, as if some repulsive force is stretching space-time itself. Enter dark energy, a phenomenon so baffling it makes up nearly 70% of the universe's total energy. Think of it like this: if the cosmos were a loaf of raisin bread baking in an oven, dark energy isn't just making the dough rise, it's causing the raisin's galaxies to hurtle away from each other faster and faster, as if the oven itself were growing exponentially. Here's where it gets stranger. Dark matter pulls while dark energy pushes. One builds cosmic scaffolding, the other tears it apart. And yet, despite their opposing roles, they might be two sides of the same coin. Some theories suggest dark energy could be a property of space itself, a cosmological constant Einstein once proposed, then dismissed as his greatest blunder. Others speculate it's a dynamic field, evolving over time. As for dark matter, candidates range from undiscovered particles to primordial black holes forged in the universe's first seconds. The hunt for answers is anything but passive. Deep underground, detectors like Xenon 1T wait for the faintest whisper of a dark matter particle colliding with ordinary atoms. In space, telescopes like Euclid map the distortions of light caused by dark matter's gravity, tracing its hidden web, and every new observation peels back another layer of mystery. When astronomers measured the cosmic microwave background, they found dark energy's fingerprints imprinted in the afterglow of the Big Bang. When they studied colliding galaxy clusters, they saw dark matter's presence in the way gravity bent light around it, like a lens forged from shadows. What makes these enigmas so thrilling isn't just their scale, it's what they reveal about our place in the cosmos. We're surrounded by forces we can't see, can't touch, and barely understand, yet they dictate the universe's fate. Will dark energy's relentless push eventually tear galaxies apart? Or could it decay, allowing gravity to pull everything back together in a cosmic reversal? The answers lie in the darkness, waiting to be uncovered. And as we probe deeper, we're reminded that the universe's greatest stories aren't written in the stars we see, but in the invisible threads weaving them together. The universe is full of signals, some natural, some unexplained, and a few so peculiar they ignite the imagination. When the wow signal blared across Ohio in 1977, or when Oumuamua accelerated without a visible comet tail, one tantalizing question lingered: could these be more than cosmic oddities? Could they be evidence of intelligence beyond Earth? That's the driving force behind SETI, the search for extraterrestrial intelligence, a decades-long mission to scan the skies for whispers from the stars. Imagine tuning a radio dial through static, searching for a voice in the noise, except this dial spans the entire galaxy, and the voice might not even be a voice at all. SETI approach is equal parts methodical and hopeful. Massive radio telescopes like the Allen Telescope Array in California listen for narrowband signals, frequencies too precise to arise naturally. Think of it like searching for a flashlight in a pitch-black forest. Natural cosmic events produce broad, chaotic bursts of radio waves, but a deliberate transmission would stand out like a laser beam. Yet the challenge is staggering. The universe is vast and signals weaken over distance. A transmission from 1,000 light-years away would arrive as a whisper, drowned out by cosmic background noise or earthly interference. Then there's the question of timing. Civilizations might rise and fall in the blink of a cosmic eye. A signal sent millennia ago could reach us long after its senders vanished. Or worse, we might be listening on the wrong frequency or at the wrong time, like two ships passing in the interstellar dark. Some scientists argue we should also look for physical evidence, like probes or megastructures. The idea isn't as far-fetched as it sounds. After all, humanity has already sent Voyager beyond our solar system. Could Oumuamua have been someone else's Voyager, tumbling silently past our telescopes before slipping back into the void? But SETI isn't just about finding aliens, it's about understanding our place in the cosmos. Every unexplained signal, every anomalous object, forces us to confront how little we know. The universe is 13.8 billion years old. If life arose here, why not elsewhere? And if it did, what forms might it take? A civilization 1,000,000 years ahead of us might harness energies we can't fathom, leaving traces we'd struggle to recognize. Perhaps the most profound lesson of SETI is patience. The cosmos operates on timescales far beyond human lifetimes. A single observation might be a fluke, but the search itself is a testament to curiosity, a way of saying, we're here, we're listening, and we're not alone in wanting to know. Whether the next big discovery comes from a radio telescope or a flicker of light in the data, one thing's certain: the universe has more stories to tell, and we've only just begun to listen. The night sky is a grand illusion, a masterpiece of cosmic sleight of hand where most of the show happens beyond the limits of human vision. Consider this: if you stare at the Milky Way's shimmering band, you're witnessing less than 1% of what's actually there. The rest, the swirling currents of dark matter, the seething gamma-ray bubbles, the ghostly tendrils of the cosmic web, exists in wavelengths our eyes never evolved to see. It's like standing in a concert hall and hearing only the faintest hum of a violin while an entire orchestra plays around you. Take infrared light, for example. To us, a nebula might look like a wisp of smoke against the black. But through the James Webb Space Telescope's infrared eyes, that same nebula erupts into towering cliffs of gas and dust, lit from within by newborn stars. Or radio waves silent to our ears, yet carrying the whispers of pulsars and the echoes of the Big Bang itself. Even the very fabric of space is alive with vibrations we can't feel, as gravitational waves stretch and compress the universe like ripples on a pond. This sensory limitation isn't just a curiosity, it's a fundamental barrier to understanding the cosmos. For centuries, astronomers mapped only what they could see, unaware that visible light was just a sliver of the electromagnetic spectrum. It wasn't until the 20th century that we began building eyes for other wavelengths, revealing a universe far stranger than we'd imagined. X-ray telescopes uncovered black holes devouring stars. Ultraviolet sensors exposed the violent births of galaxies. Each new window shattered old assumptions, proving that reality isn't just what we perceive, it's what we've yet to detect. The implications stretch beyond astronomy. If we'd evolved in a world bathed in radio waves, our history books might tell of celestial symphonies instead of constellations. Our art, our myths, even our conception of beauty would be shaped by invisible forces. This disconnect raises a humbling question. How many cosmic wonders remain hidden simply because we lack the right tools to perceive them? Perhaps the greatest lesson lies in the gaps themselves. Every time we invent a new way to see, or whether through neutrino detectors or gravitational wave observatories, the universe rewards us with fresh mysteries. Dark matter still eludes direct detection. Dark energy defies explanation, and somewhere out there, beyond the reach of our finest instruments, the next great revelation waits, reminding us that the universe isn't just bigger than we imagine, it's bigger than we can imagine. The true frontier isn't space, it's the boundary of our own perception. Science fiction has always been a mirror, one that distorts, exaggerates, and sometimes eerily predicts the truths of our universe. Long before telescopes confirmed the existence of black holes, writers like H.G. Wells were spinning tales of cosmic voids swallowing stars whole. And when Einstein's equations hinted at wormholes, tunnels through space-time, science fiction had already mapped them as interstellar highways in stories like Madeleine Ellingle's A Wrinkle in Time. But this isn't just about fiction guessing right. It's a dance between imagination and discovery, where each pushes the other forward. Take Tabby Star, with its bizarre dimming pattern that sparked whispers of alien megastructures. That idea didn't come from nowhere. It was inspired by Freeman Dyson's theoretical sphere, a concept born in a scientific paper but popularized by sci-fi. Suddenly, a wild hypothesis became a legitimate avenue of research, proving that even the most outlandish stories can sharpen our scientific curiosity. The influence runs both ways. When astronomers detected fast radio bursts, their mysterious repetitions felt ripped straight from a contact-style first contact story. And Oumuamua's odd acceleration, it reignited debates about extraterrestrial probes, a trope sci-fi has explored for decades. These parallels aren't coincidental. Sci-fi writers often work with scientists, weaving real physics into their narratives, which in turn primes the public and researchers to recognize strangeness when it appears in the data. Arthur C. Clarke's geostationary satellite seemed fantastical in the 1940s, yet 20 years later, they were orbiting Earth. Similarly, the warp drives of Star Trek now inform serious theoretical work on Alcubierre bubbles, where spacetime itself could be bent to enable faster-than-light travel. But here's the twist: reality keeps outdoing fiction. The Great Attractor's gravitational pull or the Fermi Bubbles' gamma-ray glow would feel over the top in a screenplay, yet they're everyday mysteries in astrophysics. Sci-fi imagines, science tests, and when the two collide, magic happens. The zombie star's repeated explosions defy fictional tropes. No writer would dare script a supernova with sequels. HD1, that impossibly massive early galaxy, upends our cosmic timelines more dramatically than any time travel plot. Even the cosmic web, with its filamentary threads linking galaxies, feels like a backdrop from Doctor Who, except it's the real scaffolding of the universe. What makes this synergy so powerful is its humility. Sci-fi reminds scientists to dream bigger, while science grounds fiction in plausibility. When Carl Sagan wrote Contact, he didn't just imagine alien signals. He built the math behind them, influencing real SETI protocols. Today, as we scan for technosignatures or debate the ethics of messaging extraterrestrials, we're living in a dialogue that started on the page. The next time you gaze at the stars, remember, the line between science and fiction isn't a wall, it's a bridge. And somewhere on that bridge between the known and the imagined, the next great cosmic revelation might be waiting, inspired by a story we haven't even written yet. Centuries ago, when astronomers gazed upward with nothing but their eyes and rudimentary tools, the cosmos was a realm of divine signs and celestial omens. A sudden brightening in the sky, a new star or nova, could send kingdoms into panic, interpreted as a portent of war or the death of a king. Comets, with their ghostly tails, were harbingers of doom, their appearances meticulously recorded in ancient texts alongside plagues and invasions. These phenomena weren't just mysteries, they were messages woven into the fabric of mythology and fear. Fast forward to the Renaissance, when Tycho Brahe tracked the supernova of 1572, proving the heavens weren't immutable. His observations shattered Aristotelian dogma, yet even he couldn't explain what caused that stellar explosion. For all their brilliance, past astronomers were like detectives without fingerprints or forensics, piecing together clues from shadows and whispers. What's fascinating isn't just how far we've come, it's how history repeats itself. Today's cosmic anomalies, from fast radio bursts to dark flow, are the modern equivalents of those ancient omens. They unsettle our understanding just as novas unsettled medieval minds, demanding new frameworks to explain the inexplicable. The difference: we have tools those early stargazers couldn't dream of. Where they saw a comet and imagined disaster, we see Oumuamua and calculate its trajectory with supercomputers. Yet the awe remains. The wow signal would have been a divine sign in another era. Today, it's a tantalizing blip in a radio telescope's data. The human instinct to seek meaning in the unknown hasn't changed, only the lens through which we view it. Consider the parallels. Just as Brahe's nova forced a re-evaluation of the cosmos, Tabby Star challenges our models of stellar behavior. The Great Attractor, pulling galaxies toward the unseen, echoes the way comets once seemed to defy natural law. Even the language we use, dark matter, voids, zombie stars, carries a mythic weight, as if we're still trying to name the unnameable. The irony is delicious. The more we uncover, the more we realize how much still hides in the shadows. Future astronomers may look back at our puzzles the way we view Brahe's nova, once mysterious, now textbook. But for now, these enigmas are our celestial omens, reminding us that the universe's greatest gift isn't answers, it's the thrill of the unanswered. Perhaps that's the real lesson of history. Every era has its cosmic riddles, and every solution births new questions. The night sky that terrified our ancestors now thrills us, not because we've solved it, but because we've learned to love the chase. And somewhere out there, beyond the edge of our understanding, the next great mystery waits, not as a warning, but an invitation. The universe has always been full of surprises, but we're standing on the brink of an era that could redefine everything we think we know. With instruments like the James Webb Space Telescope already peeling back layers of cosmic history, and next-generation observatories like the Extremely Large Telescope and the Nancy Grace Roman Space Telescope set to come online within the next decade, we're not just upgrading our tools, we're unlocking entirely new ways of seeing. Imagine trying to piece together a symphony while only hearing the bass line, and then suddenly gaining access to every instrument. That's the leap we're about to take. Take dark matter, for example. Right now, it's a shadow. an invisible presence we can only infer from its gravitational pull. But with the Vera Rubin Observatory's legacy survey of space and time scanning the entire southern sky every few nights, we might finally catch its faintest whispers. By tracking how light bends around unseen mass or mapping the motions of distant stars with unprecedented precision, we could be on the verge of pinpointing what this mysterious substance actually is. Will it turn out to be undiscovered particles, as many suspect, or could it be something even stranger, like primordial black holes from the universe's first moments? The answer might be hiding in petabytes of data already being collected. Then there's the hunt for life beyond Earth. The James Webb Telescope has already sniffed out potential biosignatures in exoplanet atmospheres molecules like dimethyl sulfide, which on Earth is only produced by living organisms. But future missions like Europe's Plato or NASA's Habitable Worlds Observatory will go further. They won't just look for hints of life, they'll study entire planetary systems in infrared and optical wavelengths, searching for oceans, continents, even city lights. Picture this, a telescope so sensitive it could detect the heat signature of a metropolis on a world orbiting another star. It sounds like science fiction, but the technology is already in development. But the real game changer might be gravitational wave astronomy. Right now, LIGO and Virgo detect collisions between black holes and neutron stars, cataclysmic events that send ripples through spacetime. But the upcoming Laser Interferometer Space Antenna, or LISA, will open a new window. Floating in space, free from Earth's vibrations, LISA could hear the mergers of supermassive black holes, the birth cries of the universe's first stars, even relics from before the Big Bang. It's like switching from a microphone in a windstorm to a studio-quality recorder. Suddenly, the universe's soundtrack becomes crystal clear. And let's not forget the wild cards, the discoveries we can't even predict. Every time we've built a more powerful telescope, we've stumbled upon phenomena that defy explanation. Galaxies that shouldn't exist, particles moving faster than light, only to find a calibration error, but still, or cosmic structures so vast they challenge the very notion of cosmic homogeneity. With instruments like the Square Kilometre Array Radio Telescope Network mapping hydrogen across the universe, or the 30-meter telescope resolving individual stars in distant galaxies, we're guaranteed to find something that sends theorists back to their chalkboards. What's thrilling isn't just the potential answers, it's the questions we haven't even thought to ask yet. The next decade of astronomy won't just fill gaps in our knowledge. It'll tear down entire walls, revealing landscapes we never knew existed. Whether it's solving the mystery of dark energy, capturing the first clear image of an exoplanet's surface, or detecting a signal that reshapes our understanding of life's place in the cosmos, one thing's certain: the universe has been keeping its best secrets. And soon, thanks to these technological marvels, it won't have a choice but to start sharing them. When a cosmic mystery makes headlines, it doesn't just capture attention, it ignites imagination. Take Oumuamua, the interstellar visitor that rocketed through our solar system. Within days of its discovery, social media erupted with theories, from alien probes to fragments of a shattered world. News outlets splashed sensational headlines, while forums buzzed with debates over its strange acceleration. It wasn't just scientists scrutinizing the data. Armchair astronomers and sci-fi enthusiasts joined the conversation, dissecting every pixel of telescope images for clues. This collective obsession reveals something profound. Humanity's hunger for the unknown isn't confined to labs or observatories. It's woven into our culture, our art, even our memes. The WOW signal, a 72-second blip from 1977, proves how enduring these mysteries can be. Decades later, it still sparks documentaries, podcasts, and Reddit threads dissecting its origin. Why? Because it represents the ultimate. What if a fleeting moment where the universe seemed to whisper directly to us? The signal's ambiguity is its power. Without a clear explanation, it becomes a canvas for our hopes and fears, reflecting everything from religious awe to existential dread. When a mystery lingers, it doesn't fade, it evolves, growing richer with each retelling. Then there's Tabby Star, whose erratic dimming birthed the alien megastructure theory. What started as a scientific paper became a viral sensation, with headlines proclaiming, "Have we found aliens?" The public's reaction wasn't just curiosity, it was participatory. Citizen scientists sifted through data via projects like Planet Hunters, while artists rendered fantastical Dyson spheres in digital galleries. This blending of science and storytelling isn't accidental. Cosmic anomalies force us to confront the limits of our knowledge, and in that space between fact and speculation, creativity thrives. But public fascination isn't always benign. The Black Knight satellite conspiracy, for instance, spiraled from a misunderstood thermal blanket photo into elaborate tales of ancient alien surveillance. Here, the line between wonder and misinformation blurs, yet even these fringe theories highlight a universal truth. We're hardwired to seek patterns, to fill gaps with narratives, whether grounded or fantastical. The internet amplifies this, turning cosmic oddities into shared cultural touchstones, debated in YouTube comments and late-night live streams. What ties these reactions together is their emotional core. A fast radio burst isn't just a data point, it's a pulse in the dark, a reminder that the universe is alive with phenomena we can't yet explain. When HD1, that impossibly massive early galaxy, challenged our cosmic timelines, it wasn't just astronomers who felt the jolt, it was anyone who's ever looked up and wondered, what else is out there? These mysteries democratize awe, inviting everyone to the table, from PhDs to curious teens with telescopes in their backyards. The stories we tell about cosmic enigmas reveal as much about us as they do about the universe. They're mirrors reflecting our longing for connection, our fear of isolation, and our unshakable belief that the cosmos holds more than we can yet see. And perhaps that's the greatest gift of these unsolved puzzles, not the answers they might one day provide, but the conversations they spark today, weaving science into the fabric of our shared imagination. The universe loves a good mystery, but not every cosmic enigma remains unsolved. For every wow, signal, or dark matter puzzle that lingers, there are celestial riddles we've cracked wide open, stories where science has triumphed over speculation. Take the Martian canals, for instance. In the late 19th century, astronomer Giovanni Schiaparelli mapped what he thought were straight lines crisscrossing the red planet, sparking feverish tales of an alien-built irrigation network. Decades later, higher-resolution telescopes revealed the truth, an optical illusion, tricks of light and shadow on a barren landscape. What once fueled novels and wild theories now stands as a cautionary tale, a reminder of how easily our minds can weave patterns where none exist. Then there's the infamous Face on Mars, a rock formation photographed by Viking 1 in 1976 that seemed to stare back at us with eerily humanoid features. Tabloids ran wild, but when the Mars Global Surveyor revisited the site in the 90s, it captured the same formation in sharper detail, just a weathered mesa, its eyes and mouth mere bumps and cracks sculpted by wind and time. Yet even after debunking, the face endures in pop culture, proof of how deeply we crave the extraordinary. Some myths collapse under the weight of evidence, while others transform into deeper truths. The Planet X panic of the early 20th century, fueled by irregularities in Neptune's orbit, led to Pluto's discovery only for further study to reveal those irregularities were measurement errors. Yet the hunt for a real ninth planet beyond Pluto continues, with tantalizing gravitational clues suggesting something massive might still lurk in the Kuiper belt. The myth birthed a real scientific quest. Even the zodiac, that ancient celestial roadmap, crumbles under modern scrutiny. The constellations haven't aligned with their astrological meanings for millennia due to Earth's wobbling axis, yet millions still check horoscopes daily. It's a testament to how myths outlive their astronomical roots, embedding themselves in culture long after science moves on. But here's the beauty of debunking. It doesn't diminish wonder, it refines it. When we learn pulsars aren't alien beacons but spinning neutron stars, or that gamma-ray bursts stem from colliding stars rather than cosmic warfare, the universe becomes no less astonishing. If anything, stripping away the fiction reveals a reality far richer, one where truth, not fantasy, fuels our curiosity. The thrill isn't in clinging to myths, it's in uncovering what's stranger than we ever imagined. After all, who needs ancient astronauts when you've got black holes singing in B-flat? These cosmic mysteries do more than dazzle us with their strangeness. They hold up a mirror to humanity itself, reflecting both our insignificance and our extraordinary potential. Consider the wow signal, a fleeting whisper from the void that could have been anything, a dying star, a glitch, or perhaps a greeting from beings we'll never meet. Its very ambiguity forces us to confront a humbling truth. We're listeners in a universe that may not even know we're here. Yet the fact that we're listening at all, that we've built instruments to catch such whispers, is a testament to our relentless drive to make sense of the unknown. Take the Fermi Bubbles, those towering gamma-ray structures stretching above and below our galaxy. They remind us that even our Milky Way, home to hundreds of billions of stars, has a violent, explosive history we're only beginning to piece together. We orbit an unremarkable star in a quiet suburb of this galaxy, yet we've managed to decode the aftereffects of a black hole's tantrum from millions of years ago. That's the paradox of our place in the cosmos. We're impossibly small, but our reach, our understanding extends far beyond our physical scale. Then there's the Great Attractor, yanking entire galaxies toward some unseen destiny. It's a cosmic reminder that for all our achievements, we're still caught in currents we can't control, like leaves floating down a river whose source and mouth remain hidden. But here's the twist: we've mapped that river. We've traced its flow across billions of light years, using math and ingenuity to chart forces that would have been pure mythology to our ancestors. The universe may dwarf us, but we've learned to read its hidden language. Perhaps the most profound lesson lies in the cosmic web, that vast filamentary network connecting everything. We're not just observers of this web. We're embedded in it, our atoms forged in the same stellar furnaces as the stars above. When we study these structures, we're not just exploring the universe, we're exploring our own origins. Every mystery solved, from the composition of diamond planets to the nature of dark matter, is another thread in the story of how stardust became conscious enough to ponder itself. That's the real gift of these enigmas. They don't just humble us, they invite us to keep asking, keep searching. Because in a cosmos where dead stars can flicker back to life and entire galaxies can vanish into voids, the only true limitation would be assuming we've already figured it all out. The night sky isn't just a spectacle, it's a conversation, one we're only just beginning to understand. And every time we point a telescope at the unknown, we're replying, we're here. We're paying attention. Ever looked up at the night sky and wondered how to catch a glimpse of the universe's weirdest wonders? You don't need $1 million observatory, just a bit of know-how and a decent amateur telescope. Let's start with pulsars, those cosmic lighthouses. While you won't see their actual spin, they're too small and distant, you can spot their host nebulae. The Crab Nebula, for example, houses a pulsar at its heart. On a clear, moonless night, point your telescope toward Taurus. With a 6-inch aperture or larger, you'll see the nebula's ghostly tendrils, a glowing remnant of the supernova that birthed the pulsar. The thrill, knowing that faint shimmer is powered by a city-sized star corpse spinning 30 times per second. For nebulae, the key is dark skies and the right filters. The Orion Nebula is a beginner's dream, bright enough to dazzle even through light pollution. But to hunt rarities like the Red Rectangle, you'll need an oxygen 3 filter to amplify its crimson hues against the black. Aim for nights with steady, seeing minimal atmospheric turbulence, and let your eyes adjust for at least 20 minutes. Nebulae reveal their secrets slowly, like a photograph developing in real time. Then there's the ultimate challenge, catching an interstellar visitor like Oumuamua's next cousin. Join online communities like the Minor Planet Center to track newly discovered comets or asteroids. With a star chart app and patience, you might spot one as a faint star that moves against the backdrop over hours. The magic, you're witnessing something that doesn't even belong to our solar system, a traveler from the cosmic deep. Pro tip, pair your observing with radio astronomy. Websites like the SETI Institute's feed let you listen to pulsar signals in real time. Imagine hearing the crab pulsar's rapid clicks through your headphones while its light reaches your eyes, a multisensory echo of a star's heartbeat across thousands of years. The universe isn't just for professionals. Every time you train your telescope on these oddities, you're stepping into a tradition of discovery that stretches back to Galileo. And who knows, the next cosmic mystery might reveal itself not in a lab's data dump, but through your eyepiece, waiting for a curious soul to notice. Behind every cosmic mystery lies a human story, a curious mind staring at data, chasing a hunch, or sometimes stumbling onto the extraordinary by pure accident. Take Vera Rubin, the astronomer whose meticulous observations of galaxy rotations revealed the first hard evidence of dark matter. In the 1970s, while studying the Andromeda Galaxy, she noticed something impossible. Stars at the galaxy's edge moved just as fast as those near the center, defying Newton's laws. The only explanation, an invisible gravitational force, dark matter holding everything together. Rubin's work revolutionized cosmology, yet she faced an uphill battle for recognition in a male-dominated field. Her persistence not only reshaped our understanding of the universe, but also paved the way for generations of women in science. Then there's Jocelyn Bell Burnell, whose name is forever tied to one of astronomy's greatest serendipities. As a graduate student in 1967, she spotted rhythmic pulses in radio telescope data, blips so precise they seemed artificial. Dubbed LGM-1 short for Little Green Men, these signals turned out to be the first pulsars rapidly spinning neutron stars. The discovery earned her advisor a Nobel Prize, while Bell Burnell's contributions were initially overlooked. Yet her legacy endures, not just for the breakthrough itself, but for her grace in advocating for equity in science, proving that curiosity and resilience can outshine even the brightest cosmic phenomena. Some discoveries come from sheer tenacity, like Clyde Tombaugh's hunt for Planet X. In 1930, armed with a blink comparator, a device that flickered between photographic plates, he spent months scanning the sky for moving dots. The tedious work paid off when he spotted Pluto, a faint speck against the starry backdrop. Though Pluto's planetary status has since been debated, Tombaugh's dedication reminds us that exploration isn't always about high-tech tools. Sometimes it's about patience and an unwavering eye for detail. Fast forward to modern trailblazers like Tabitha Boyajian, whose namesake star, Tabby Star captivated the world with its bizarre dimming patterns. As the lead author of the study that first documented its odd behavior, Boötes embraced the public's fascination, crowdfunding follow-up research and proving that science thrives when shared beyond academic circles. Her approach reflects a new era of collaboration, where citizen scientists and professionals work side by side to decode the cosmos. What ties these pioneers together isn't just their discoveries, but their willingness to question the unknown. They stared at anomalies others dismissed, fought for their ideas, and in doing so, expanded the boundaries of human knowledge. Their stories aren't just footnotes in textbooks, they're proof that the universe's greatest secrets are often uncovered by those daring enough to look closer, think deeper, and challenge the status quo. And as new mysteries emerge, from fast radio bursts to dark flow, today's scientists stand on their shoulders, ready to write the next chapter in this never-ending quest for understanding. Cosmic history is filled with riddles that once seemed impossible until they weren't. Take quasars, those brilliant beacons shining from the edges of the observable universe. When first detected in the 1950s, their pinpoint brilliance outshone entire galaxies, defying explanation. Some astronomers speculated they were nearby stars with bizarre properties, while others feared they'd stumbled upon secret Soviet space weapons. The truth turned out to be far more spectacular. Quasars are the blazing hearts of young galaxies, powered by supermassive black holes guzzling gas at ferocious rates. What was once a cosmic conundrum is now a textbook example of astrophysics in action, proof that even the most bewildering phenomena can crack under the weight of curiosity and observation. But for every mystery solved, another rises to take its place. Dark energy, the elusive force accelerating the universe's expansion, remains one of modern science's most profound puzzles. We can measure its effects. Galaxies flying apart faster than gravity should allow, yet its nature is utterly opaque. Is it a property of space itself, as Einstein once suggested? A new kind of field or particle, or something beyond our current physics entirely? The frustration is palpable. We're watching the universe's most dramatic act unfold, yet we don't even know the name of the lead actor. This push and pull between known and unknown is what makes cosmology so thrilling. When pulsars were discovered in the 1960s, their perfectly timed radio pulses had astronomers seriously considering extraterrestrial origins. Today, we know them as spinning neutron stars, cosmic lighthouses born from supernova. Yet their discovery paved the way for new mysteries like fast radio bursts, which still resist full explanation. It's a cycle as old as science itself. Each answer unlocks fresh questions, keeping the boundaries of knowledge forever just out of reach. Consider the evolution of our solar system's story. For centuries, comets were omens of doom, their erratic paths confounding astronomers. Then came Edmund Halley, who predicted the return of his eponymous comet using Newton's laws, turning chaos into clockwork. Yet modern planetary science grapples with fresh enigmas, like the peculiar orbits of distant Kuiper belt objects hinting at a possible Planet 9, a ghost world we've yet to lay eyes on. The tools have changed, but the essence remains. The cosmos delights in keeping us guessing. What sets the enduring mysteries apart is their resistance to our best tools. Dark matter, for instance, outweighs normal matter 5 to 1, yet decades of underground detectors and space telescopes haven't caught a single particle of it. Meanwhile, solved mysteries often reveal their secrets through technological leaps. The James Webb Space Telescope, for example, has demystified galaxy formation by spotting impossibly bright early galaxies, forcing us to revise models. But in doing so, it's uncovered new head-scratchers like HD1. The beauty lies in the balance. If every mystery were solved, science would stagnate. If none yielded to inquiry, we'd lose hope. It's the interplay, the slow unraveling of some threads while others tighten into knots, that drives discovery forward. And somewhere between the known and the unknown, between Halley's Comet and dark energy's shadow, lies the sweet spot, the joy of the chase, the thrill of the not yet understood, and the quiet certainty that the universe will always have one more card up its sleeve. Some of the most groundbreaking discoveries in astronomy didn't come from high-powered telescopes or elite research labs. They came from everyday people staring at their computer screens, captivated by the cosmos. Take Galaxy Zoo, a project that turned astronomy on its head by inviting volunteers to classify galaxies from telescope images. What started as a simple online experiment in 2007 quickly became a revolution. Over 50,000 amateur scientists joined the effort, sifting through 1 million galaxy snapshots, work that would have taken professional astronomers decades. And then something extraordinary happened. A Dutch schoolteacher named Hanny van Arkel spotted a strange, glowing green blob in one image, unlike anything researchers had seen before. Dubbed Hanny's Voorwerp, this enigmatic object turned out to be a cosmic ghost, a quasar's light echo illuminating a cloud of gas, offering scientists a rare glimpse into the violent lives of supermassive black holes. What makes citizen science so powerful isn't just the volume of data processed, it's the fresh eyes that spot what algorithms miss. Professional astronomers are trained to focus on specific patterns, but amateurs bring unfiltered curiosity. When volunteers combing through Kepler Space Telescope data noticed unusual dips in starlight, they weren't just identifying exoplanets, they were flagging bizarre systems like Tabby Star, whose erratic dimming sparked global intrigue. Even NASA, a backyard worlds project, relies on volunteers to scan infrared maps for nearby brown dwarfs and rogue planets, discoveries that could rewrite our understanding of the solar neighborhood. The tools have never been more accessible. Apps like Zooniverse let anyone hunt for supernova or track asteroid rotations, while platforms like SETI at home harness idle computers to analyze radio signals for extraterrestrial patterns. Some projects don't even require a screen. The American Association of Variable Star Observers trains amateurs to monitor pulsating stars from their backyards, contributing data that professionals use to test stellar models. But here's the real magic. Citizen science isn't just about crowdsourcing labor. It's about rewriting the narrative of who gets to participate in discovery. When a retired radio engineer in Australia spotted a peculiar burst in his homemade telescope feed, it led to the identification of a new class of energetic pulsars. When a Japanese amateur astronomer photographed a mysterious flash near Jupiter, professionals confirmed it as a rare meteor impact on the gas giant. These moments prove that the universe doesn't discriminate. Its secrets are there for anyone bold enough to look. Perhaps the most profound impact lies in the partnerships forged. Projects like Planet Hunters unite PhDs and high school students, grandmothers and grad students, all poring over the same data. In a field often dominated by institutional gatekeeping, these collaborations remind us that wonder is the great equalizer. After all, the next cosmic anomaly might not be found by a telescope's algorithm, but by a teacher, a taxi driver, or a kid with a laptop, staring at the stars and seeing something no one else noticed. And in that moment, they're not just observers, they're explorers. Cosmic mysteries don't just live in scientific journals. They leap off the page and into our stories, songs, and screens, becoming part of the way we make sense of the universe. Think of the pulsating monolith in 2001, A Space Odyssey, its eerie alignment with Jupiter mirroring humanity's awe at forces beyond comprehension, or the haunting radio signals in Contact, a direct nod to the wow. Signal blending real science with the timeless question, Are we alone? These aren't just plot devices, they're cultural touchstones bridging the gap between data and dreams. Music, too, echoes the cosmos's strangeness. David Bowie's Space Oddity captured the isolation of the void long before we understood the true silence between stars. Meanwhile, bands like Muse weave dark matter and supermassive black holes into their lyrics, turning astrophysics into anthems. Even classical composers like Gustav Holst imagine the planets as musical movements, giving Mars the sound of war and Neptune the whisper of infinite distance. Art doesn't just reflect science, it humanizes it, translating equations into emotions we can feel. But the influence runs deeper than entertainment. Ancient cultures saw comets as omens. Today, Tabby Star's flickers inspire sci-fi about Dyson spheres. The Black Knight satellite conspiracy birthed novels, podcasts, and even a Doctor Who episode, proving how easily mystery sparks myth. And when fast radio bursts were discovered, they didn't just puzzle scientists, they fueled X-Files-style tales of alien transmissions. This interplay isn't accidental. Cosmic anomalies tap into our primal need to narrate the unknown, to turn data points into legends. Yet the most fascinating twist. Sometimes art predicts science. Star Trek dreamed up warp drive before physicists debated Alcubierre bubbles. Interstellar's black hole visualizations preceded the first real image of M87. Even The Twilight Zone explored multiverses decades before quantum theory made them mainstream. Creativity doesn't just follow discovery, it races ahead, sketching possibilities science hasn't yet proven. What makes this symbiosis so powerful is its honesty. The universe is weird, and our stories admit it. Whether it's a blockbuster bending space-time or a songwriter channeling the loneliness of a rogue planet, these retellings remind us science and art aren't rivals. They're twin lenses, each revealing facets the other can't. So the next time you hear a pulsar's rhythm in a synth line or spot a nebula's palette in a painting, remember, you're witnessing the oldest human tradition. We've always looked up and thought, what if? And in that question, science and storytelling become one. Imagine sending a message into the void, not knowing who or what might hear it. That's the dilemma at the heart of messaging extraterrestrial intelligence, the deliberate broadcasting of signals into space. While SETI listens for alien transmissions, METI actively announces our presence, a move that divides scientists like few other topics. On one side, visionaries like the late Stephen Hawking warned that alerting advanced civilizations could be catastrophic, comparing it to Europeans arriving in the Americas, an encounter that rarely ended well for the less technologically advanced. Yet others, like astronomer Douglas Vakoch, argue that hiding is futile. Any civilization capable of detecting our radio leaks from TV broadcasts could already know we're here. The debate isn't just academic, it's a high-stakes gamble with humanity's future. But broadcasting isn't the only ethical minefield. Consider planetary protection, the rules preventing Earth microbes from contaminating other worlds, and vice versa. When NASA Perseverance rover drilled into Mars, it followed strict sterilization protocols to avoid seeding the red planet with terrestrial bacteria. Why? Because discovering life on Mars would lose all meaning if we couldn't prove it wasn't just a hitchhiker from Florida. The reverse risk is equally chilling. Samples returned from Enceladus or Europa could harbor alien pathogens, prompting NASA to design multi-layered containment systems reminiscent of sci-fi horror plots. Critics call these measures excessive, but history offers a cautionary tale. When European explorers introduced smallpox to the Americas, it wiped out civilizations. The cosmos might hold threats we can't even conceive. Then there's the question of cosmic conservation. Mining asteroids for platinum or helium-3 could fuel Earth's economy. but what if we destroy pristine celestial bodies in the process? The Moon's craters preserve a record of solar system history, while Martian glaciers might hold clues to climate cycles spanning millennia. Treating space as a free-for-all risks repeating Earth's environmental mistakes on a galactic scale. Some propose interstellar national parks, preserving regions like Saturn's rings or Europa's oceans as off-limits to exploitation, not just for science but for their intrinsic wonder. After all, if we pave over the cosmos, what's left to inspire future generations? The stakes soar when we contemplate altering other worlds. Terraforming Mars, once a sci-fi fantasy, is now a serious discussion. Pumping greenhouse gases to warm the planet or seeding algae to produce oxygen could make it habitable, but at what cost? Erasing Mars' native environment before we've fully studied it may be the ultimate arrogance. Even starlight isn't sacred. Proposals to dim the sun with orbital mirrors to combat climate change could unintentionally blind astronomers to distant exoplanets. Every intervention ripples across the cosmos in ways we can't predict. Perhaps the deepest ethical question is one of humility. In our rush to explore, do we risk becoming the invaders we've long feared in stories? The universe has operated for billions of years without us. Do we have the right to rearrange its pieces? There are no easy answers, only trade-offs between curiosity and caution, progress and preservation. As we stand on the brink of becoming an interstellar species, these dilemmas remind us that exploration isn't just about what we can do, it's about what we should. The final frontier isn't just a place, it's a mirror reflecting our values back at us, and what it shows might determine not just our survival, but our legacy among the stars. Building the tools to unlock the universe's secrets doesn't come cheap. The James Webb Space Telescope's $10 billion price tag could fund a small country's education system for years, while a single Mars rover mission costs more than blockbuster movies and Olympic Games combined. Yet these investments yield dividends far beyond their staggering dollar amounts. Consider how Hubble's Deep Field image, captured by a telescope initially dismissed as a bloated government project, revolutionized our understanding of galaxy formation by revealing thousands of previously unseen galaxies in a patch of sky no bigger than a grain of sand held at arm's length. That single photograph didn't just fill textbooks, it reshaped humanity's cosmic perspective, proving the universe contained at least 10 times more galaxies than we'd imagined. The funding models behind these endeavors are as innovative as the discoveries themselves. Traditional government agencies like NASA and ESA compete for taxpayer dollars against earthly priorities like healthcare and infrastructure, while private ventures like SpaceX/launch costs through reusable rockets. Citizen-supported projects break new ground too. The SETI Institute's Allen Telescope Array was partly funded by tech philanthropists, and crowdfunding campaigns have resurrected stalled missions to study atmospheric anomalies. Even developing nations are entering the arena. India's Chandrayaan lunar mission cost less than Hollywood's Gravity while proving water exists on the Moon, a discovery with profound implications for future space colonies. Beyond pure science, these investments spark technological revolutions with down-to-earth benefits. The charge-coupled devices developed for astronomy now power every smartphone camera. GPS relies on relativistic corrections first calculated for orbiting telescopes. Medical MRI scanners descend from radio astronomy technology designed to map distant quasars. When engineers created Webb's ultra-precise mirror segments, they pioneered manufacturing techniques now used in laser eye surgery and semiconductor production. The list cascades through everyday life, from scratch-resistant lenses to memory foam mattresses, all born from solving space's unique challenges. Perhaps most crucially, astronomy operates as humanity's ultimate long-term bet. While political and economic cycles measure progress in years, cosmic revelations unfold across generations. The Vera Rubin Observatory's decade-long sky survey won't just catalog asteroids, it'll create a motion picture of the universe's evolution, helping us predict galaxy collisions billions of years in our future. Such patience yields unexpected rewards. When radio astronomers studying pulsars discovered subtle timing anomalies in the 1970s, they weren't just debugging equipment, they'd accidentally found the first evidence for gravitational waves, a phenomenon that would take another 40 years to directly detect. This isn't just spending it sowing seeds for civilizations we'll never meet. The knowledge that galaxies accelerate away from us, that black holes hum in gravitational waves, or that life's ingredients rain down on exoplanets doesn't put food on tables today. But like planting olive trees whose fruit your grandchildren will harvest, astronomy cultivates a legacy of wonder and possibility. When budgets tighten, critics ask why we stare at the stars instead of fixing roads. The answer whispers back from every telescope's eyepiece, because gazing outward is how we ultimately see ourselves. There's something transformative about standing under an open sky when the universe decides to put on a show. Take Sarah, a nurse from Arizona who'd never given much thought to astronomy until she drove 4 hours to witness the 2017 total solar eclipse. As the moon's shadow raced across the desert at 2,000 miles per hour, she described the moment totality hit as time freezing, the sky plunging into twilight, stars winking awake in the middle of the day, and the sun's corona blooming like a silver flower. What stayed with her wasn't just the spectacle, but the shared silence of hundreds of strangers suddenly holding their breath together. For 2 minutes, we weren't just people in a parking lot, she recalls. We were part of something ancient, something bigger than all of us. That eclipse reignited her childhood curiosity. Now she leads stargazing workshops for patients recovering from trauma, using the night sky as a reminder that healing isn't linear, just like the cosmos' rhythms. Then there's Marcus, a truck driver who spent decades watching highways blur past his windshield until the Leonid meteor storm of 2001 pulled him over to the shoulder. It was like the sky was alive, he says. Not just a few shooting stars, hundreds, maybe thousands, every hour. What moved him wasn't just the fireballs streaking overhead, but realizing many of those specks of light had been traveling through space for centuries before vaporizing in Earth's atmosphere right above him. That night, he started keeping a journal of celestial events on his dashboard, and later enrolled in online astronomy courses during rest stops. Today, he delivers telescopes to underserved schools along his routes, turning his rig into a mobile classroom. For some, these encounters arrive unannounced. Leela, a software engineer in Norway, was battling insomnia when she stumbled outside during the Aurora Borealis' most intense display in 20 years. The whole sky was rippling with green and purple, she says. Not just static lights, they were dancing like the atmosphere was breathing. That sleepless night became the inspiration for her app that tracks space weather alerts, helping others chase those elusive curtains of light. What threads these stories together isn't just awe, it's the way cosmic events collapse the distance between the infinite and the intimate. A farmer in Chile who replanted his vineyard after seeing Halley's Comet in 1986, convinced its passing was a sign to take risks. A teenager in Japan who photographed the International Space Station crossing the moon, realizing for the first time that humans really lived up there. Even small moments, a family spotting Jupiter's moons through a borrowed telescope, or friends watching a satellite flare ignite like a match struck against the night, carry weight far beyond their scientific explanation. These aren't passive observations, they're conversations, When the universe whispers whether through a meteor's fleeting streak or a planet's steady glow, it invites us to whisper back. To plant gardens under meteor showers, to paint galaxies on hospital walls, to name stars after loved ones gone too soon. The sky doesn't just belong to astronomers with PhDs. It's a canvas for anyone brave enough to look up and let it change them. And sometimes all it takes is one clear night, one unexpected burst of light, to remind us we're not just observers of the cosmos, we're part of its story. As we wrap up this journey through 15 of the universe's most bewildering phenomena, it's impossible not to feel a sense of awe at just how little we truly understand. These cosmic oddities, from the eerie precision of the Red Rectangle Nebula to the gravitational enigma of the Great Attractor, aren't just scientific curiosities. They're invitations to question, to challenge our assumptions, and to embrace the humbling truth that reality is far stranger than fiction. Think about it. Every time we've peeled back a layer of the cosmos, we've uncovered something unexpected. The wow signal taught us how a single blip of radio noise could ignite decades of speculation. Oumuamua reminded us that interstellar visitors might be tumbling past our doorstep when we least expect them. And dark matter, it continues to taunt us, silently shaping the universe while eluding every attempt to pin it down. These mysteries aren't roadblocks, they're signposts, pointing toward discoveries we haven't even dreamed of yet. What's truly thrilling is that you don't need a PhD or a billion-dollar telescope to be part of this adventure. Some of the most groundbreaking observations have come from amateur astronomers with backyard telescopes, citizen scientists sifting through data, or simply people who looked up at the right moment and noticed something extraordinary. The night sky is the ultimate democratic laboratory, open to anyone willing to gaze upward and wonder. So where do we go from here? The universe isn't done surprising us. With missions like the Vera Rubin Observatory set to map the sky in unprecedented detail, or the James Webb Telescope probing the atmospheres of distant exoplanets, the next great cosmic revelation could be just around the corner. Maybe it'll be the detection of a technosignature proof we're not alone. Or perhaps we'll finally crack the code of dark energy, unlocking the fate of the cosmos itself. Whatever comes next, one thing's certain, the story is far from over. As you step away from this video, take that curiosity with you. Share your wildest theories in the comments. Could Tabby Star's dimming be alien megastructures or just a swarm of comets? Have you ever spotted something unexplainable in the night sky? Let's keep the conversation going. And if you're hungry for more cosmic wonders, hit that subscribe button so you don't miss our next deep dive into the universe's greatest mysteries. Remember, the cosmos isn't just something we observe, it's something we're part of. So keep looking up, stay baffled, and never stop asking, what if? The next chapter is yours.